Hello everyone. I hope all of you are good and have enjoyed your vacation. You have rested in this week and all of you are safe and sound from Corona. Since we are moving to online education, so we'll be meeting online via this Microsoft Teams and sometimes I'll be giving you these recorded lectures. We'll have this lecture as a demo, and in this lecture we'll start a topic, an important topic in programming, which is called functions. So let's start. Here I have a file, a program, simple program called func1.cpp, and if we go inside, we'll see that it's a very simple program. It just outputs hello world. So to give you a demo, I'll compile it and run it. Compile and run it, and you see that it just outputs hello world as we saw in the source code. So we know that the execution of a C program starts at the start of the main, and it would go on sequentially execute your code line by line until it reaches this end of the curly bracket, which was opened at the start of main, and then your program will terminate. So the program flow basically continues linearly. So in this line 4, at the end of line 4, we open this curly bracket, which tells us that main has started, the body of main has started, and then the execution of your program will proceed sequentially line by line until it reaches the end of main, which is signified by the closing of this curly bracket, which was opened in line 4. Here in line 9, we are closing this curly bracket and our program will terminate when it reaches here. So this is exactly what happened when we compiled and ran this program. It started at main, and then it basically came here in line 6. It executed this command cout hello world, which printed the string hello world on the screen, and then it moved forward sequentially, as I said, and in line 8 it did return 0, and in line 9 basically it terminated. So just to show you that, I mean, you guys already know, but just to show you, emphasize the point that it executes linearly and it goes on sequentially. We'll just try to emphasize the point and do multiple printfs here. So here I'll change it to line 8 and num is equal to 22, and here we'll output num. Here we'll do goodbye. So as we expect the execution to proceed linearly, we'll see that first of all it will come on line 6, print hello world, and then on line 8 it will print line 8, and then line 10 it would create a variable called num, initialize it to the value 22. Line 11 it will output the value of num, so we should expect the value 22 to be printed here, and then it will arrive here, and line 13 it would print goodbye and come to the end of main, and it will exit basically. So we do the compilation again, and then we run our program, and we see that it proceeds exactly as we expected, line by line, sequentially from the start of the main until the end of the main, and then it terminates. So it will basically execute everything and anything that you have written inside those curly brackets which delimit the main. So all this to say that the program flow basically executes sequentially from the start of main to the end of the main. In the first half of this semester, we studied some control structures which are provided by every language, including C++, which let us modify this flow of the execution. So we studied if statements, if else statements, which basically let us conditionally execute some part of the program and skip some other part based on some condition. And then we studied loops, while loops, do while loops, and for loops, which basically help us repeatedly execute some part of our program. Some instructions are continuously executed repeatedly, in the sense that the execution flow, it moves sequentially, but whenever it encounters an if statement, it will, based on the condition, it will skip some instructions. So again, the linear flow will be broken and it will jump to some other part based on a condition. And similarly, in for loops, the linear flow is again broken, and when the execution flow, it proceeds linearly, and when it reaches the end of the loop, instead of going forward, if the condition is true, the loop condition is true, it will jump back. So instead of going forward, it will jump back and re-execute the body of the loop. Okay? So again, the flow is disturbed. I mean, the flow is changed based on our condition, and instead of executing forward linearly as we saw in this program, it jumps back to the start of the loop and executes the body of the loop again. And it continues to do so, like jumping back and executing the body, as long as the condition of the loop remains true. So these were the two structures of statements that we saw in C++, that they permit us to modify this linear flow of execution. Functions basically also let us modify the linear flow of execution, but in a different way. First of all, we'll see why do we need function and how do they help us. So the reason for functions is, or using functions is, that sometimes we have to do some task multiple times at different points in our program. Let's say we have a 1,000-line program. So at line, let's say 25, you need to do some task. So you write the code. Let's say the code is of 20 lines. So at line 25, you'll write those 20 lines which do the task. And then at line 100 again, you need to do the same task. So again, you write those 20 lines again. At line 400, you need to do that task again. So again, you have to retype those 20 lines. And let's say in that 1,000-line programs, you need to do that particular task 20 times. Okay? So you will be writing those 20 lines every time you have to do that task. So you'll be writing those lines 20 times. But it's the same task that we are doing. The same task we are doing, and writing it 20 times is like not only cumbersome, but also kind of wasteful. Okay? It's just a repetitive task that we have to retype again all the 20 lines. You can say, you can argue that we don't have to retype the 20 lines all the time again. You can copy paste them 20 times. Copy pasting 20 lines is much easier than retyping 20 lines all the time. Okay, so if we take that argument, let me pose another twist in this situation. Let's say you copy pasted those 20 lines 20 times. That was easy to do. Now you need to modify something in that task. So let's say out of these 20 lines, you have to modify 4 lines to accomplish that modification. So the first at the first point where you wrote the task 20 lines, you go there and modify 4 lines, and you go to the next place where you had typed those 20 lines or copy pasted those 20 lines, and you modify 4 lines over there also. So now that you need to change this code, you have to go again to all these 20 places and you have to modify it 20 times. Again, you can say that we can modify the first 20 lines and then copy paste those 20 lines to the rest of the 19 points where we will copy paste this code. This problem has a couple of issues. First of all, copy pasting, again, it's like easier than retyping, but it still takes time. You have to go to the each place and then copy paste 20 lines, go to the next place and then 20 lines. It still takes time. And secondly, especially for this modification case, there is a good chance that sometimes you will forget or you will miss some of the places where you need to do the modification. For small programs, you might not realize the importance of this statement, but for big programs where you have like thousands of hundreds of thousands of lines, it is very easy to miss something. Functions basically are a solution to this problem. You have to repetitively do same task again. Instead of copy pasting or retyping the code of that task 20 times or 100 times, you just write it once and you reuse that code 100 times. And secondly, when you need to modify this code, you only modify it at that one place where you had written that code. You do not need to modify it in the 100 places. So you modify it where you had written that code, and this modification will be reflected in all those 100 places where you are using that code automatically. Let me give you an example. I'll give you an example and then I'll be like explaining the bits and pieces in the next lecture. So what we do is the code that we have to write or use repeatedly, we write it separately outside of main in a function. So let us say that I write a function and it has a very complicated code that we'll have to reuse multiple times in our code. In this example, I'll replace this complicated code by a very simple print cout statement. But imagine in your head that this code is like very complicated. So I'll write this code simply outside of main in a function. So what a function is, basically we'll talk about it in detail in the next lecture, but a function basically consists of a return type. Let's say, we'll see what it means, but let's say this is the return type of my function, a name of my function, let's say I call it function 1, and some arguments to the function, which for the moment will return remain empty. So this is like a parenthesis will contain arguments, but in this case there are no arguments, we'll keep them empty. And then we have the body of the function, which is enclosed by curly braces. So in this code function, basically this is a function and I'll type my code here inside those curly braces. And as I said, it could be some very complicated code, but here in this example, we are replacing that complicated code with a simple print statement. I'll just print is my complicated code. And let's assume that we need to use this complicated code at multiple points in our code. So what will happen is that instead of copy pasting this complicated code multiple times in our program, we will basically write it once inside this function. Okay? And then in our code, wherever we need to use this complicated code, we will call this function. I'll explain in the next lecture what calling a function means but basically for the moment imagine that calling means using the code of the function. So here I use my complicated code for the first time, and let's say here I use it second time, here I use it third time, and here I use it for the fourth time. And let's say we could use it as many times as we want. So basically ordinarily we would have, without functions, we would have copy pasted this complicated code at all these lines. At line number 11, 14, 18, and 21, we would have copy pasted this complicated code. Here it's 4 times, but it could have been 100 times. So function basically lets us avoid this copy pasting multiple times. Basically calling a function would be using the code of that function wherever we have called this function. So here we would call 4 times. So we will see in the execution of this program that this can help. Just a minute.